Good morning, esteemed space explorers. My name is Tiffany Travis, and it is my honor to welcome you to this morning's Global Networking Forum, Gateway, humanity's first lunar space station. I will serve as your moderator today, a moderator who does not have a background in science or technology or engineering. I am a storyteller who happens to have the unique privilege of working every day with the individuals to my right. These people are pioneers working collaboratively with international partners throughout the globe to create history by building and launching humanity's first space station to orbit the moon. Today, we're going to tell you Gateway's story, a story that is rooted in the foundation of international and commercial collaboration. This story is building upon decades of success with the International Space Station. Gateway is an enabler of the emerging lunar economy and an extension of more than 20 years of global partnerships and technology gained from our heritage in low Earth orbit. Today, you will hear how public-private partnerships spanning more than a dozen countries on 3 continents are actively fabricating the core elements of Gateway and preparing for utilization payloads that will usher in a new era of lunar science, where we will unravel some of the greatest mysteries of our solar system for the benefit of all. After today's forum, you will leave with a better understanding of how Gateway will provide benefits for all of humanity through onboard science investigations focused on heliophysics, life science, and human benefits. Growth through the aerospace industry, through the application of existing and leading-edge technologies in deep space, advanced solar electric propulsion, and autonomy. And you will understand why Gateway is an invaluable component of the larger Artemis missions and advanced deep space exploration, inspiring the next generation of Earth's children when international teams of astronauts fly and live on Gateway for longer duration missions at the moon and prepare for journeys to Mars. It is now my pleasure to welcome our panelists. We have Dr. John Alanson, Gateway Program Manager, Sean Fuller, Gateway International Partner Manager, Dina Cantella, ISS Program Operations Integration Manager and former Gateway Mission Integration and Utilization Manager, and then a gentleman who doesn't really need an introduction for this audience, but Mr. Koichi Wakata, astronaut and senior advisor with JAXA. So, to begin our story, John, can you please briefly share the origin story of our Gateway program and where we are today, and give us our setting?
All right, so good morning. Thank you, Tiffany. So setting the scene for our story. Imagine, if you will, you're in cislunar space. You are looking for a place to establish a foothold from which you can explore the entirety of the lunar surface in a sustainable way. You're looking for a home away from home for your crew who are doing that exploration. You're looking for a place where you can aggregate different capabilities in cislunar space to enable future exploration. You're looking for a place where you can do science in deep space away from the influence of Earth's magnetosphere. You're looking for a place where you can bring international partners together in an effort to build out humanity's exploration of our solar system. Enter Gateway. This is what Gateway is about. Gateway is a full space station, though much smaller than the ISS. We are in process of building Gateway at this point in time. We have an initial capability that we will be launching in just a couple of years' time that includes the power and propulsion element being built by Maxar Technologies, our commercial partner, and a habitation and logistics outpost being built by Northrop Grumman, another commercial partner. Those elements will launch together initially and form the initial capability of Gateway. We then have contributions from international partners, ESA providing an international habitat and a European or an Esprit refueling module, as well as other components. We have JAXA providing a life support system. Those things are all being provided by our combined international capability. We will launch with different launch providers, and we will build out this fundamental, this baseline capability that enables the exploration, as I said, of the lunar surface and sets the stage for that future exploration into our solar system. Now, as I mentioned, the Gateway station is significantly smaller than the ISS. We'll talk a little bit more about the comparisons there. If you consider the International Space Station today to be about a 6-bedroom house, our Gateway station will be about a studio apartment size, but we'll be in cislunar orbit. We will be crewed about 30 days a year, rather than continuously crewed like the ISS is. That 30 days a year means 11 months out of the year we are operating autonomously. We are building that autonomous capability for the space station so that we, one, demonstrate that capability both within cislunar exploration, but also as a needed capability for exploration beyond. And we will be flying the Gateway station in a near rectilinear halo orbit. We chose that orbit for multiple reasons. It is a very efficient orbit for us to maintain the station's orbit, maintain its access to the lunar surface. It provides great opportunities for science. It provides great communications capabilities and an opportunity for multiple different entities to be able to aggregate in that orbit for exploration of the lunar surface and beyond. We will build out that capability piecemeal. I mentioned the initial capability that will launch just a couple years from now. And we will add to that capability through the Artemis missions currently planned. Artemis 4 will see the delivery of the international habitat provided by ESA with the incorporation of life support systems developed by JAXA. Artemis 5 will see the delivery of the Esprit refueling module. And in that time frame, we will also have delivery of the ARM, Canadarm3, provided by CSA. Artemis 6 will see the delivery of an airlock and will complete the baseline configuration of the Gateway so that we then can provide all of that exploration support, that sustained capability in cislunar space that forms the cornerstone of the future Artemis missions to come. This creates a blueprint for how we explore beyond Earth. And we do so together with our international partners. We do so in conjunction with the world for the benefit of humankind.
Thank you, John. That sets the story and the stage very nicely for our main characters. The main characters of our global story, Gateway's international partners. Sean, can you talk about the importance of the Artemis Accords and how they factor into Gateway's success? And then maybe walk us through Gateway's international partnerships, what similarities and differences there are between the ISS and Gateway programs?
Absolutely, and good morning. It's a pleasure to be with you all. Through the Artemis Accords, which I'm proud to say we have now 29 nations that have signed as part of this venture of humanity going beyond low Earth orbit, with more coming in the future. It's really important that we do that as a global effort, building on all of our capabilities as we expand human and scientific discovery farther into the cosmos, not only at the lunar surface, but looking ahead to Mars in the future. Through these partnerships and through the principles that we adhere to in the Artemis Accords, we're doing that for all of mankind, through our peaceful purposes, interoperability, allowing different elements to come together, as well as the other tenets of the Artemis Accords. We'll build that, leveraging off of partnerships that have been long, and new partnerships as well, and more in the future. It's a very exciting time for all of us. It's great to see the representation here from those agencies around the world as we embark on this next big endeavor for humankind. It's going to lead us to great new technologies and advancement, not only for our systems to get to lunar space, but develop those systems and advance it to take humans onto Mars. I'm looking forward to those first boot prints on Mars. We'll start that with the human landing of the first woman and first person of color from the US on the lunar surface, and our partners and colleagues in the future. Those are going to be great new steps. While doing that, we'll also have multiple new scientific discoveries, our platform that will exist in a regime that hasn't been there before, new resources, learning more about the lunar South Pole, more about our own home as we get ready to venture out into the future. And we do that and epitomize the Artemis Accords in our gateway. We bring that together using those tenets to build our basis of that partnership of getting ready to advance and advance into the future. And so what are the elements that let that happen on Gateway? We have our partners, as John talked about, building the different elements. First one, the Canadian arm, building off of what we call Canada Arm 3, building off of that heritage of space shuttle and then on space station as it's used today. But it's a new advancement in technology. And that's what a lot of Gateway is about, is taking that next step in technology advancement. It has greater capabilities on autonomy. We'll have the capability without crew on Gateway, driving the arm, continuing our research, doing activities, getting ready for the crew arrival, and then after crew departure to get ready for the next mission. A huge advancement that's going to help us, as you might imagine, for activities on the lunar surface or in the future on Mars as well. In addition to the Canada arm, we have contributions from other partners as well. The deep impacts that will advance our capabilities, building off of ISS and then moving to the future. Our European colleagues are building hardware right now in Italy, bringing together the first elements of the IHAB module. That will be our home, where crews will sleep, where they will gather, where they will eat, and where they will do work and scientific research inside of Gateway. That will become our core element of it, where we will have the crews arrive via Orion, enter into Gateway, and begin their work there. In addition, on our first elements, the European colleagues will have a lunar communication system that will relay from the lunar surface through Gateway back to the Earth, become that comm hub for us looking into the future. The IHAB will have great capabilities with it, also including our JAXA colleagues in the thermal control and life support systems. But I'll let Koichi tell you a bit more about that in the future. In addition to the IHAB, our European colleagues have a wonderful window. Can't imagine a Gateway without a window where we'll have crews looking in one window down to the lunar surface, turn around out of another window to Earth. What a great perspective. I'm sure you all can imagine what that might be like to see those viewpoints from very far, 250,000 miles away from Earth. That will be a great capability, and also advancing our technologies in that module with refueling. That refueling will help us sustain Gateway for the planned 15-year life and beyond. We'll take those lessons we've learned on ISS as they get ready to celebrate their 25th year here in orbit. We will look the same, build that technology, the capability for Gateway to go much further in its mission, supporting that lunar exploration, as well as a stepping off point going out to Mars. Going on to other components of Gateway, we mentioned our Japanese colleagues, but also logistics. Logistics will be a key portion of Gateway and the Artemis exploration. You've got to feed, utilization, all the supplies, clothing, all that is going to be key elements for us, taking what we use today on Space Station, but now going much farther out into our capability. All that will tie together into what we call the Gateway and a Gateway partnership. Each of us contributing to a much greater cause, building a bigger integrated elements together. All that will move ahead in these elements that allow us to do the research in this unique platform, not only while the crew is there, but also while the crew isn't there. In addition to the robotic arm, there is utilization platforms external on Gateway. Those will host the science instruments that will be in this regime, as John mentioned, outside of the Van Allen belts, in a different world that we haven't been in before, allowing this platform for great research, even from the beginning of Gateway.
Thank you, Sean. So that leads us to one of the main conflicts in our story. Every story has to have conflict, right? Every good story, at least. Here we go. Thank you, slides. They're working. Radiation. Radiation, among other deep space exploration challenge, is really a conflict that our global science community, the heroes of our story, must address to ensure the safety of our crew and integrity of our investments. Dina, with your extensive background working in utilization for both the ISS and Gateway, can you share highlights from the utilization successes we have learned in lower Earth orbit, that heritage story, if you will, and how we are now ushering in a very new, different era of science?
Sure. Thank you, Tiffany. So let me first, I'll hit radiation, but first let me talk about the differences between ISS and Gateway. I know that you all know that ISS is a premier laboratory in low Earth orbit, but in terms of its size, for example, it has a NASA laboratory, a JAXA laboratory, an ESA laboratory, a Russian laboratory, and that's in addition to habitation and other modules on board for stowage. We have really extensive power and communication, and we have very good access to Earth, so we have multiple cargo missions that come and go on ISS. So we can do a lot of science on ISS. And on Gateway, although it's smaller and it'll have less logistics, we are hoping to capitalize on the creativeness and our micronization and our capabilities on Gateway and our new technology that we'll have in order to try to use what we have on Gateway despite the size and its location further from Earth. We have a new philosophy on Gateway. It's pretty exciting. So on ISS, each of the different international partners is given an allocation, how much they can, basically we call it upmass, how much you can take onto orbit, and how much crew time, for example, is all based on a percentage of crew time, a percentage of upmass, based on your contribution. So for example, NASA contributed modules and the power and the truss and everything on the ISS, and it naturally lends itself to having a larger percentage of allocation. But on Gateway, we decided to do a different philosophy. And I like it. It's kind of Mars forward. Think about if you were going to Mars, a very small station, you'd want all the international partners to have a say in what science was going to take place on the way there, as well as on the surface, and then everyone would share in the data. And that's what the philosophy that we have on Gateway. Everyone will come to consensus on the best science for those limited spots on Gateway, and it's thus far working. It's going great, I'm excited to say. So some of the considerations that you would take into account when you're doing payload selection on Gateway. For example, you want to take advantage of the unique location and its specific orbit. So in this case, we'll talk a little bit about radiation specifically, but it's further from Earth and is in a deep space location. If you have a payload that is mostly studying microgravity, well, you can do that in low Earth orbit. So that wouldn't be as good a candidate for a payload on Gateway. Another consideration would be trying to get a payload with multiple benefits or multiple science instruments so that you can take advantage of those few slots that are available. Additionally, you want to consider payloads that would take into account the fact that the crew is not there most of the time. So if you're able to stream back science back to Earth when the crew isn't there, well, that's great. You get year-round science benefit out of those payloads. And clearly, there'll be some payloads that will have the crew operating when they get there. We'll be studying the crew, in fact. But when the crew is not there, we would like to be providing scientific benefit from Gateway. And then, of course, there's this international partner element. We would like to involve as many partners as possible in the payloads, either the development or the data sharing, and we work that out together in a consensus fashion. And so that leads me to your next part of your question about the radiation. So we've selected 3 payloads, and they are all radiation related. Those considerations taken into account, the Earth's magnetosphere is where ISS flies within the Earth's magnetosphere, and so it's protected from radiation. The magnetosphere is the region around the Earth that works with the solar wind essentially and protects the Earth from a couple of different kinds of radiation. But Gateway, on the other hand, is going to be far removed from that. Its orbit just hits the tail of the magnetosphere once in orbit. It is not very often, and so we get a chance to see deep space and the radiation that would be exposed to our crew and our equipment on the way to Mars. So Gateway's in a really unique position, and we've not studied that human spaceflight, so it's extremely exciting. Radiation, as you can imagine, is not good for the human body, and so we'll be trying to understand the countermeasures and what we can do for long durations on Gateway and also for a long duration trip to Mars. And it's not good for equipment either. You know when your laptop goes belly up and you have to do a power cycle every so often, well, you can imagine that might happen a lot more often in a high radiation environment. So we're testing methodologies and radiation hardening and what we can do in terms of our technologies there. And really studying it materials-wise outside of the Gateway as well. So there's a lot to be learned in radiation. And these 3 payloads, and you can see it on the slide, just to go through them for a moment. First of all, we have a really good international flavor to this. We use the Canadian adapters to put our external payloads on. That allows us to, in the future, change these out, and they can use the robotic arm to do so. The 2 external payloads are called Hermes and Ursa, and both of them contain multiple radiation experiments, scientific elements to them, to really get a good spectrum of study across the different energies of particles, and all the heliophysicists are pretty excited about these 2 sets of payloads, external. And on one of the payloads, we've also integrated a JAXA dust sensor. And so just to quickly segue out to that for a moment, so when we go take the lander down to the moon, you can envision that we could, through electrostatic charge or other methods, get dust on the lander. And when it comes up to dock, we could transfer some of that to Gateway. And so we want to study how much dust transfers, how much dust stays, maybe via electrostatic charge, and that's what this dust sensor will do. It could degrade our arrays or get into equipment, so it's important that we understand that environment. And so we're appreciative of our ESA and JAXA colleagues for combining their efforts in this payload. Additionally, we'll have an internal payload as well on the first launch. It's called IDA, and that one is, it's an internal dosimeter array, and it has 4 instruments. So you can see where we're going with how many instruments we have in each of these. And one of them is the same instrument as we have outside. So we'll get a chance to study the effects of the actual shell of the halo module and how that is protecting the inside of the cabin. So again, the radiation is really critical to understanding the environment, and all this will help us in the future as well by baselining the radiation for other payloads. So we're excited to see that. We're excited to get some characterization even on the first flight. It's going to be great. We'll get science back throughout the year from the different payloads. But we are looking forward to the crew coming, and we'll get some science as well from them. And I think this is where I'm going to end up passing it back.
Thank you, Dina. So that part of the story now, thank you, for the heroes, our scientists, right? We have a point of view for the story, right? And history will always tell the story, really, from the point of view of our astronauts. So, without further ado, I would love to hear, and I'm sure the audience would as well, the point of view of an astronaut, some of the differences between living aboard ISS, as well as how that compares to Gateway, and your experiences, as well as JAXA's contributions. Koichi.
Thank you, thank you, Tiffany. It's really exciting to hear what John, Sean, and Indiana presented to us. Actually, I was on board the ISS when Artemis 1 was launched last year. Actually, we launched last year on this day on the Crew 5 mission, but I was on board the station when Artemis 1 was launched. So what we are seeing today is no longer a PowerPoint presentation. Hardware is being built. SLS launch is successful, and then Orion is tested. The crew is already announced. So we are really working on this one. It's really exciting to be part of that. And I worked as a Capcom when Dina was a flight director at MCC. When a crew, Artemis 2 crew launches, after they launch, after the vehicle is tested in low Earth orbit, I cannot wait to hear the call, go for TLI. That's the permission to go to the translunar injection burn. So I'm really looking forward to it. So it's really exciting. And as for the mission controls role, as John and Sean said, 11 months out of 12 months, Gateway will be in an autonomous or remotely controlled operation. And currently on board the space station, we have 24/7 astronauts working, and in close conjunction with the mission control. But we will be on board the Gateway or lunar surface within like 5 weeks or 30 days or so. So the role of the Mission Control Center will be really significant. Right now it's significant, but even more significant because it will be remotely controlled or autonomously controlled when crew is not on board the Gateway. So the Mission Control will be more significant on the Gateway. So I will show you some of the pictures of the JAXA's contribution on the International Space Station. This program launched in 1998, the first launch of the component, and the human presence has been there since November of 2000. And this ISS program shows the strength of the international cooperation. Together we're stronger, and together we go further, and that's a perfect example, and the ISS has demonstrated that. We have encountered a lot of technical challenges through the program, but because of this international cooperation, we were able to survive. So there's a government-level agreement called the IGA, ISS, Government Intergovernmental Agreement. I'm sure it's a hell of a work who put together this document, but because of this document, we were able to survive a lot of challenges that we faced in the 2 decades. And Gateway is an extension of our international cooperation, and Japan is utilizing all the knowledge and experience that we gained in the ISS program for the Gateway program. As you can see on this one, Kibo module was launched in 2008 and 2009, and has been conducting a variety of experiments inside and outside. And we also launched a cargo supply vehicle, HTV, you can see on the upper right side, successfully 9 times, and some of the significant payloads are like the batteries, the US batteries externally located in the space station. Those are necessary equipment to provide a stable power supply to the station through to the end of the space station life, which is expected to be no earlier than 2030. And then, so after the 9 successful HTV launches, cargo supply missions to the station, JAXA is currently developing a new cargo vehicle called HTVX. And so these are what we are working on it, but all of these experience, technologies, and human resources we have gained through the ISS program, we are applying everything to the Gateway program. And if you could show the next one, we can have some examples of the JAXA's contribution. As Sean and John mentioned, we are providing the Eclipse function, as you can see on the left side, to the IHAB module, International Habitation Module, as well as the ESPRI ERM module. Components of the Eclipse function will be provided to both IHAB and ERM. So humidity and temperature control, as well as CO2 removal capabilities, those Eclipse functions are the things that JAXA is providing to the gateway. Again, we have gained a tremendous technological advancement through the ISS program by providing the Japanese experimental module Kibo to the space station. And utilizing the technologies, so we are now providing the Eclipse function to the gateway. And also, I mentioned in the previous slide of the HTV-X, which is the newer version of the HTV. That's a cargo transfer vehicle which has better or larger capability of the volume as well as the mass to launch to the ISS. But again, we are now modifying the HTV-X to be sent to the gateway. So that's a new one, gateway version, HTV-XG. So this cargo supply vehicle will be able to provide or carry 4 metric tons of cargo to the gateway. And so it's going to take a little longer than the crewed capsules that will go to the gateway. So it'll take about a month to get there, but it will be able to provide this 4 tons of metric cargo supply to the space station. If you could go to the next one. So those are the gateway contribution, the JAXA's contribution to the gateway. And gateway is there to sustainably continue the lunar operation as well as towards the Mars mission preparation. So from the gateway, we will continue to go on to the surface of the moon, and JAXA is investigating or researching and developing the items that you can see here. One of them is the navigation satellite system on the lunar side, and this is in conjunction with cooperation with international partners, NASA, ESA, and other partners. And then also we are working with Toyota Motor Company to research and develop this crewed pressurized rover. Again, this is a very necessary function for sustainable continuation of the lunar surface operation. And this vehicle will be able to operate for a total of 10,000 kilometers through the 10 years of life. And it can have 2 crew members in nominal case, and we'll be able to have 4 maximum crew member capability in an off-nominal situation. And also, as far as the lunar surface operation, currently we are working with India's ISRO for a lunar South Pole region exploration mission, which is a LUPEX. And this will have a rover, and it can do in situ analysis of the samples that is collected there. And so this will be a precursor for us to gain more data as to where to send humans to the surface of the South Pole regions. And the data gained from these missions will be fed back to the crewed pressurized rover that we are currently developing. Actually, on board the space station, we tested some liquid behavior test phenomenon in the low Earth gravity, a low gravity level. Like on the moon surface, it's about 1/6 of a G, and on Mars, it's 1/3 of a G. We know how liquid behave in 0 gravity and also in 1 gravity, but we need to figure out exactly how the oil of the lunar rover would behave in a low gravity. So we are utilizing the space station to gain data that will benefit our future system design for Luna and Mars missions. So space station, again, is a fantastic asset for technology demonstration and technological research for our mission to Mars and to the moon. And if you could go to the next one, that's it.
Yeah.
So again, the JAXA's contribution, I show some examples, but it's been really fortunate for us to be able to gain a tremendous data experience on the space station. And again, international cooperation is a key for continuous and sustainable growth of human space exploration. And we are so honored to be part of this effort.
Thank you, Koichi. We're honored to have you a part of our panel here today. So the Gateway story does not have an ending yet. We are actively in the middle of this historical story, preparing to launch the initial PPE and HALO modules. There are many more questions that we must ask and discoveries we must make before the story ends, but we are going back to the moon, and this time we are staying. And we're staying on and around the lunar surface to answer some of humanity's most challenging questions for the benefit of all. So now we're going to hear from you, our audience, our listeners. I think most of you by now should have access to the Slido QR code, so please feel free to join along in this conversation because you are the public, you are our global community, and we must hear from you. So we're going to take some Q&A, all right? So let me get this up to begin with. Okay, good question. And I'm going to direct this to the entire panel, and then you guys just jump in when it makes sense, okay? So, can the habitation duration be extended in the future? Or are the 30-day a year design limiting your life support?
All right, so I can start with that. We are starting off designing to where we have a 30-day capability, and we are looking forward to advancing capabilities where we could get out to 60, maybe even 90 days in the future with the baseline capability that we're starting with, the infrastructure that we're starting with. We do have to build on some of those capabilities in order to get to the 60 to 90 days. But the fundamental structure that we'll have in place would support it. So we are looking forward to expanding that at this point in time.
Okay,
And I'll
thank
just
you.
add to that, I'd say I think it's very important with that, like John said, you have an initial capability. The life support systems, they have the capability in there for carbon dioxide reduction, but we also scar in additional capabilities to enable for the future, to add regenerative eclipse in the future if that's where the mission takes us. I'll tell you one of the things we've learned quite a bit from our ISS colleagues is the mission 25 years after you started is a lot different than what you imagined when you first launched. And so it's one of the things we build within Gateway, taking those lessons and the capabilities for adaptability and additions in the future. And so like John said, logistics adds that, but also the systems have inherent systems capabilities that we can expand to and add in the future if that's where the mission takes us.
Okay, thanks, Sean. Thanks, John. What part will AI take in a Gateway project?
All right, so I'll start again. I'll step away from the AI specific and focus on the autonomous operations that we're working on with Gateway. So we are currently building in a hierarchical autonomous capability within the Gateway design. So we'll have a vehicle system manager, will be the top tier software capability that we're building out. It is incorporating new technologies that will allow for autonomous operations of the vehicle. That will evolve over time. As Koichi talked about, there was a role for mission control and there's a role for autonomous operations. When we initially launch, we'll have the backbone for those autonomous operations, but we'll evolve them once we understand really how the vehicle is flying in orbit. We'll evolve those capabilities to where we're more and more autonomous, building out the technology to support future long distance exploration to Mars and beyond.
Okay, thank you. And then let's see here. There's questions flooding in, and the iPad here is changing. So this is a question about eclipse. So I feel like this might be good for Koichi. Just in general, explaining more definition about about eclipse, its support, and what it adds to Gateway specifically.
Okay, so as I mentioned in the slides, the components that JAXA is providing for the Gateway, namely to the International Habitation Module and then some parts on ERM, are the components related to the temperature and humidity control, and also the CO2 removal capabilities. And so those are the fundamental functions that we are providing. And as Sean mentioned, there are some structurally scarred area that we can add additional capabilities like regenerative type environmental control and life cycle support system. That's a future plan. But in the beginning, it's the temperature and thermal control and humidity control system, and then also their CO2 removal capabilities.
Thank you, Koichi. Maybe Dina, maybe you could answer this one. Where exactly and how close to the moon will Gateway be located?
Okay, well, it's been a while since I've been in Gateway. Let me pass that buck over to John, maybe. But essentially, it's in an orbit that swings by the moon very close and then goes way out. And I don't know how many kilometers now we've decided on.
Yeah, no, that's great. So we'll be in an orbit. I think we showed it on one of the slides, right? So we'll run about 1,000 kilometers from the lunar surface. It will be our close approach. Out to about 70,000 kilometers away, about a 6.5-day orbit is what we'll be operating in that near rectilinear halo orbit. But as I said earlier too, the other piece is it gives access to the entire lunar surface. It gives us access to the poles. It gives us access to wherever it is that we want to go. It's one of the main drivers for the selection of that orbit.
Okay, thank you. Are you expecting commercial human spaceflight missions at Gateway as it has become more common for the ISS? Sean?
Yeah, so that really goes back to one of those key principles I talked about in the interoperability. And so as we build up Gateway, it's using those standards that are openly available. And so we build it with a docking system, an international docking system that is compatible with multiple different docking systems. We actually have one developed in NASA by Boeing, another one by our European colleagues referred to as IBDM, but there can be others in the future. And so with that standard, it enables these capabilities in the future. There's a lot today that we don't know what we don't know into the future. Again, if we look back early in ISS, the plan was we would have shuttle servicing ISS throughout the life. Obviously, those plans have changed and evolved, but because we have that open standard and that capability, it enabled a commercial market. So we have that same on Gateway. It is an open standard there, and so that means that other vehicles with that interface could, in the future, dock to Gateway. So certainly see that as a possibility.
And I think there's a lot of interest in this area, but maybe this might be for Dina. In general, can lunar startups get an opportunity for commercial application through utilization and autonomy in an autonomous orbital laboratory?
A lunar startup. So, of course. So I'll just say everything's up for discussion amongst the partnership. Mm-hmm. And so, again, for payloads specifically, we'll have to discuss the benefits and everything that's provided and the data sharing and everything that would be involved in that. So I think that commercial, there is a door there, and we need to just discuss how we would enable that through international partnerships as well. And then I'll just say, when you mention lunar startups, it gives me the vision of being able to control payloads on the moon, and Gateway does provide some of that. It has the comm to be able to do that. So, for example, if you were worried about latency of commanding from Earth, you could make have the crew provide driving of a rover or something like that from Gateway. So there's some opportunity there. But again, as I've mentioned, the payloads have to be very selective and I'd say very inclusive of an international partnership. So that's all part of our future discussion, I think.
Thank you very much. What are some of the strategies to enable the Gateway mission to sustain longer and be a station for Mars transit?
All right, I'll start, but feel free, folks, to jump in. So Sean mentioned a lot of the interoperability standards and the ability to bring different capabilities in the future. We view Gateway really as the cornerstone for that the Artemis missions themselves, but that forms the blueprint then for all of the future capabilities. So imagine, if you will, you want to actually establish your Mars transit vehicle. It's all hypothetical. You want to create that capability, but you want to check it out before you actually send crew out to Mars. Gateway would provide or could provide a great platform to actually check out that Mars transit vehicle before you began that journey. It is a springboard. Gateway provides that springboard out to exploration beyond even cislunar space.
Yeah, thanks, Sean. And that's a really important aspect of Gateway. A lot of times I talk about that it allows us to maximize the different elements of Artemis and of exploration for their role. And so, for example, the orbit that we're in, that lets us with SLS and Orion focus its capabilities to get to that orbit, maximize it. That's 4 crew with SLS, but not only is it Orion, John mentioned how the modules are delivered. The SLS rocket will launch our modules and Orion can tug it out there. We can maximize that capability by having Gateway in the orbit it's in. The landers, they're now focused on that mission from the Gateway, the NRH orbit, down to the surface and back, not from launching on Earth, transiting out and onto the moon. So that's part of kind of what we call sustainable, and it leads ahead to Mars exploration. There's a lot of benefits, as we know, getting out of, for the most part, Earth's gravity well, and so becoming that location where you can aggregate the pieces together for transit to Mars, do shakedown missions, if you will, around the moon, perhaps a DRO mission around the moon to shake down a Mars transit, comes back to Gateway. That's where crews come and go via Orion, and then eventually could step off from there onto Mars. So really kind of being that central hub for Artemis exploration.
I would like to just add one thing, which is
Go for it.
maybe the why, it's the criticality for sustainability at Gateway. One of the reasons is that we really do need to study the effects of radiation and essentially being in deep space on both the human body and in space systems before we go to Mars. So we need to spend time out there. And the way to do that is on a Gateway. And so I really find it to be sort of inspirational in my former job as a utilization manager that I think it's so critical that we do this testing and really understand the aspects of how we're going to get to Mars safely and bring our crews home safely. And I do think that Gateway provides that.
Thank you. What will be the maximum velocity for Gateway? How fast will it go?
I guess I would say, well, relative to what, right? So you're launching from Earth, you're going to the moon, you're flying around the moon. It's going to vary quite a bit in that orbit. Like John mentioned, it's 6.5 days around the orbit. So you're going to zoom past at Paraloon, very close to the moon, 1,000 kilometers. That's much faster than when you're at Apolloon at 70,000 kilometers away. So the velocity, and again, is your reference frame the Earth, is at the moon. It varies quite a bit throughout its mission profile.
Okay. How will NASA manage consumables for 30 days of crew on board Gateway?
I'm sorry, I didn't hear the question.
Sorry? How will NASA manage consumables for 30 days of crew on board Gateway? I'm assuming, how will we eat? Koichi?
I'll start with a little bit, and maybe Denny can talk about how an ISS and Koichi, you're one of the consumers of it as well, right? So one of the things that we look at is in our mission profiles, logistics vehicles, and so you plan ahead in your consumables, consumable usage, and you launch them on the logistics vehicle. Part of the aggregating everything together, Orion itself has certain capabilities for 4 crew for about 21 days from its life support systems and what's launched on there. Aggregation of it using Gateway, using the Gateway consumables and also the systems in it, the carbon dioxide removal system, that's going to be very key to us as well for managing much longer stays. And so we'll use it by launching on logistics vehicles, planning ahead. Imagine one of our criteria is going to be the logistics vehicle has arrived at Gateway and successfully docked before we commit to launching crew for the mission to Gateway and then down to the lunar surface as well. We can bring the logistics to Gateway, and then as the crew gets there, offload them onto the lander as needed, used on Gateway for that entire mission.
Okay, well, maybe what I'll do is just paint the picture that there you are, you're in the Orion capsule, and you arrive at Gateway, and previously docked, we would have a Dragon XL. We'd have a cargo flight that would be packed full of things like your food, your shirts, some water, some additional crew items, but also anything needed for your systems. For example, your toilet that you're going to have, any like a chemical that might blend with your urine to take the bacteria out. You have a number of consumables, oxygen, But you've got to open the hatch. You open the hatch, and there it all is. You'll pull out the center section of the items and stow all those in different places, and maybe you can use that Dragon as a pantry. You can go in there, you'll have a food section. If you're lucky, we send ice cream and a freezer, that kind of thing. But that will be kind of the layout. As Sean said, critical, you might be time critical in needing to transfer items to the lander. And so the lander might have some items, or the lander might be using some of the items from the Dragon as well. So the crew will have to manually do all of that transfer as well. They might be installing oxygen tanks. There's a lot involved in consumables, I'd say, from that perspective. Anything from you?
Well, I just wanted to mention that I don't know how much you understand this, how hard it is to do the cargo handling on board the space station. Space station is a large volume, but we spend many days or many months, every year for the cargo handling when we have a large amount of cargo arriving on the Cygnus or Dragon cargo or HTV capsule. And then compared to the space station, gateway is very small. So we have to be very efficient, and we have to be very thoughtful about how efficiently we can operate the cargo handling. The volume is very important, but we understand the volume is very small on the gateways.
Thank you. This next question is one that's on my level. Describe the toilet facilities on Gateway. It's a bathroom question. Many people ask about going to the bathroom on space. That's part of the many, many questions we get. And Gateway has a unique system of how they're going to handle that. John?
All right, I can start, but feel free. So Gateway, actually in our core capabilities designed into the Gateway system, we currently do not have a waste management system designed in. We will use the Orion capability that is provided by Orion. That's one of the factors that would be considered for future expansion if we were going to stay longer on Gateway. So currently, that's where we are. There are definitely options for waste management system for a toilet in the future, but in our core capabilities right now, we're relying on the other systems that are coming to Gateway or leaving from Gateway to provide those capabilities.
And I guess if I can just add to that, so you might be scratching your head and saying, well, why is that? Why isn't there a toilet ingrained in? One of the things we've learned over the many years of ISS, and if you think about the Gateway mission, 30, 60, 90 days even, but it's not crewed all the time. Water stagnation is a big challenge, a big problem. On ISS, I'm sure, Koichi, you probably had times where you were battling that in the systems. And so we take that in and think about that. And so could you design a toilet into the Gateway? Absolutely. Water stagnation and taking that technical challenge of that and what might be required in crew time to get one set up versus torn down at the end of a mission, and then the technical risk you have of the water and what the microbes and whatnot that could grow in it, the systems with water just sitting in it, not exercised during the uncrewed periods, kind of leads us down the path that John talked about of other options for maybe a mission use toilet via some vehicles that aren't there full time as well. Seems to be a better option for it. We do scar some capability in IHAB in case that needs to be added in the future. But big picture, we're not looking to have one within Gateway itself, and mainly because of that technical challenge of water stagnation and what that does to systems. We want to make sure that the crew, when they arrive, it's a relatively short duration. They're focusing on the science research they're doing and the lunar surface activities there, and not maintenance on the station.
And I'll just add from ISS, so we currently have 4 toilets on board ISS. We have one in the U.S. segment, but it's a Russian toilet. And then we have 2 in the Russian segment, and one of them newly arrived, and so it's kind of having some startup transients, I'd say. And then we have one that we've been testing for Orion. And in all cases, that toilet gives us difficulty, and it's in constant use. It's not in dormancy, like Sean said. So we're constantly having to shuffle the crew members to this toilet, shuffle them to that toilet, also for maintenance, regular maintenance, but also because the toilets are just difficult in space. So like I said, there's chemicals that you have to put into the urine itself, and it really is quite the problem. So that's zero gravity. Now, it's something we will have to solve for the lunar surface as well, and that's a lot of water to launch and not be able to reclaim it. That's what we do on ISS. We take the urine, we put a lot of filters on it and take out the brine, which is I like to call it the yellow stuff. You take that out, you recycle it through really fine filters, and you're able to re-drink the water. It's really, really important for a trip to Mars. It'll be very important for long duration stays on the moon. So it is a technology that we're all working on. JAXA, of course, is trying to work on that as well. And it's critical. But certainly in this early stages, it wouldn't make sense to try to overcome those challenges for long periods of dormancy. So that the crew that was on Gateway will come back and forth into the Orion.
And then ISS, again, is a fantastic asset for the testing of the new toilet, for the Orion's toilet that we extensively tested on board the space station last year. It's going on, but we're getting a lot of data. And not only the toilet system itself, but when you talk about the consumables, the wipes that we use on board the station right now, we have plenty of supplies, but as we talked, the logistics supply will be very limited on the Gateway. So even like a wipe, paper wipes, we need to consider maybe more efficient. Maybe a smaller wipe is good enough for future missions. So we are getting a lot of good data by testing the new Orion toilet on board the space station.
Great question. Okay, moving on. This is for Koichi. How do you think being so far from Earth for extended periods of time will affect the astronauts both mentally and physically?
So, if the question is about the moon missions or?
Yes, so essentially saying now that we're moving out longer and longer, have you started, how would that impact you mentally and physically?
I think on board the space station, we can use a telephone call from the space station to your friends and family, and we have once a week of a TV chat, family conference, usually on Saturday or Sunday. And that is really nice because you can talk as if you are, talking with somebody, on a different country or something. Mm-hmm. But when we go to far beyond low Earth orbit and far beyond the moon, especially like Mars, then you cannot have the real-time conversation. You need to make a text or email. You have to make a video recording and send it. You cannot have a real-time conversation. That will be very different, I think, which humans have never experienced. We are testing that on the ground for a long-duration Mars simulation mission like happening in Johnson Space Center at NASA, for example. So psychologically, I think the fact that we will not be able to talk directly with somebody real-time, like on the ground, may be affecting some, psychological health, but we're already testing it. And at the same time, like food items and crew, towels and hygiene items. Those small things actually make you really feel refreshed and to be able to work with with comfort. So there are small things that we need to be able to consider in order to make our lives really vivid and then healthy for a longer duration flight beyond the low Earth orbit.
Thank you. And I think we may have time for one last question. Are there plans to have an international partner for the airlock? Airlock. Are there plans to have an international partner for the airlock?
Yeah, so it's one of the opportunities we certainly have out there, right? As we talk about Gateway and its elements, and airlock is a part of it. It's the last element that we'll assemble on Gateway in Artemis 6, and it is an opportunity out there. I'll tell you, kind of stay tuned. But as part of Artemis, I talked about Artemis Accords. It enables those for the future. I think hopefully in a not too distant future, you'll hear something coming our way as we talk about that partnership and the airlock coming to Gateway.
Thank you, Sean. I think that about wraps up our Q&A. We just have just a little bit of time left. I wanted to thank all of our panelists. Thank you for joining us here today. Thank you for joining this story to our audience. You are the most important part of the story, right? You have to hear the Gateway story, and we're so glad that you were here today to hear it from us and from these pioneers in exploration. Thank you so much.
Thank you all.